And yet another question without a diagram, so we need to draw one ourselves. We'll start by reading the question. Kevin is standing at the top of a ladder picking apples from an apple tree. So we have an apple tree, and Kevin is standing at the top of a ladder that's propped up against it. He's up in the tree on the ladder. The ladder itself is 7 meters long and making a 70-degree angle with the ground. You can imagine there's some sort of right angle in here. He tosses the apples into a basket located 5.4 meters from the base of the ladder, but it's on the opposite side of the tree. So now I've got a basket over here. And that total distance here is 5.4 meters. Determine the distance of the base of the ladder from the tree. So what's nice about this question is that it's actually broken into pieces. So you don't need to figure out immediately, part B, if Kevin looks down, what is the angle of depression? No, we've got some help, we've got some guidance here. And so we start with just our first triangle. So part A, I'm going to do in blue, just so that we can tell. So we're only looking at this triangle right here for part A. So I know the hypotenuse, and it's asking the distance between the base of the ladder and the tree, which would be adjacent right here. And so hypotenuse and adjacent for part A, I'm going to use cosine. Oops, sorry. I'll just call it A for adjacent over the hypotenuse. And A will be 7 times, make sure my calculator is on, 7 times cosine of 70, which is 2.4 meters. And that's your answer. Oh, and they ask in exact meters, so just 2 meters is what we're going to say. And we're done part A. Part B is a little bit trickier. So we know that this is 2 meters. Now I'm going to switch to green, just to differentiate. We know that this section here is 2 meters. Then we should be able to figure out this distance here. Should be able to find out something about this other triangle that we haven't even thought about so far. So how we do that is 5.4 is the total distance, subtract the 2 meters that are between the ladder and the tree, and that tells me that that length is 3.4 meters. Once I've done that, now I know something about my triangle, but the angle of depression is actually measured from the horizontal downwards. That's my final thing that I'm looking for. Well, if we look closely, and I'll use a highlighter just to kind of help us out, we have a rectangle, which means that these two triangles that are formed are actually identical. So my angle between the ground and the hypotenuse is going to be equal to my angle of depression. So, going back to my green pen, I do know a side. I need another side though. I'm still not done. So I need to figure out the height of my tree. Because if you're going to solve for an angle in a triangle, you need 2 sides minimum to fill in 2 out of your 3 variables in any of your trig functions. So for part B, this is a little trickier. I'm going to first solve for the height of my tree. And for that, I have to go back to my original triangle, this guy right here. Now this time I'm dealing with the opposite and the hypotenuse. So sine of 70 equals the height divided by 7, and the height will then be equal to 7 times sine of 70, so known as 6.5, or 6.6 more like meters. Now that I know two sides of my new triangle, and I'm just going to resketch it here so we kind of can visualize it better, I know that this is 3.4 meters along the bottom. I know my tree is 6.6 meters tall. Now I can calculate my angle of inclination, which is equal to that angle of depression if we were looking from the horizontal and downward. In this case, I've got my opposite and my adjacent, so I'm going to use tan here. So tan theta equals 6.6 divided by 3.4. Theta would then be tan inverse of 6.6 divided by 3.4, or 63 degrees. And you can round to the nearest degree, and that's perfectly fine. That's my angle of depression. And that's how you do this question.